Cool. All right. So hi, my name is Griffin Renaro.
Hi, my name is Grace Simonton.
And I'm Victoria Stefoglo.
And we're here with the Hyperborea team and Ian Wells to ask them a few questions about how they got to where they are. So Ian, the first question is for you. How did the project get started?
So it's a bit of a long story. I'll try to keep it pretty brief. Essentially, last year when I was hired to the Hyper Lab, I expressed my interest in photography to the lab PI, Jake. So that ended up getting me working on something called Schlieren imaging over the summer during the pandemic. I essentially was stuck at home. I had extra free time on my hands, and I decided to see if I could essentially convert a standard DSLR camera into a Schlieren imaging camera. Essentially what that does is lets you see density gradients in the air. So you can see like things moving through the air, disturbances, gases, any sort of leaks that are in front of this mirror. I ended up creating this system, and I went into the physical lab building, TFRB, once I got back to WSU campus. The idea essentially was to use this Schlieren imaging system that I had just built over the summer to see how liquid nitrogen, when it is poured on a surface, looks in Schlieren imaging. So essentially I went in, I did this wash, and I think it was a week or 2 weeks later, Jake posted a link to the NASA Big Idea Challenge in one of the team's channels that we use. So we talked back and forth a little bit after that about some possible ideas. And essentially, Jake and I realized we could attempt to use cryogenic liquids to mitigate lunar dust. We went into the lab, we tested again to evaluate that hypothesis. And that's kind of how it all got started.
That's really interesting. So Ian, you started this team when you were a sophomore. So a lot of teams in Hyper are usually done by grad students and usually have more of a higher level of influence when it comes to the project itself. So by starting your own team, was there any fear of like an interviewing process for people you were looking for or anything like that?
Absolutely. I feel if I wasn't afraid, something probably would have been wrong. I definitely had a lot of hesitancy just jumping right into it. But I had some great mentorship and essentially came up with an action plan to take it one step at a time so we could get everyone involved. Yeah, it was a process, to be sure, and I'm still learning, but yeah.
So this question is directed more towards everybody, but what were the specific roles assigned to everybody?
I guess I could go first. So I'm Lauren Rising. I'm a sophomore in mechanical engineering here at Wazoo. And on the team, I am helping with safety. So more specifically, building a safety plan, and then also taking a look at risk assessment and mitigation.
I can go next. I'm Camden Butekofer, also a sophomore in mechanical engineering here at WSU. My current role in the team is that of experimental design. I'm going through one of Jake Leachman's courses on the Hyperborea, or not the Hyperborea, the Hyper website. And a primary goal of that is to kind of consolidate all of our information and be able to put it in a format that when it comes time is very easy to, I forget the name of what it's like a report basically. It's very easily to transition into that, make that step forward, basically having everything set up.
So Hi everyone, I'm John Busse. I'm a freshman material science and engineering major. Super excited to be on this team. And early on, right in the first development stage of this project, I was primarily helping out with figuring out a simulant for the lunar dust. So as a material scientist, I was kind of using that materials to help, as I was a consultant since I work in another lab with the Hyperborea team. And so to work on our method for taking dust off of spacesuits, we needed something to act like dust. So my role was doing research to figure out what kind of those dust simulants are, as well as primarily working with Mount St. Helens ash. So 40 years ago, when Mount St. Helens exploded, the geology department filled up 100 barrels worth of ash off of the top of some of the buildings on campus. And that ash just floating around. And so one of our professors had an idea for us to try to use that ash to act as like lunar regolith. So I spent most of last semester working towards characterizing it, figuring out how big it is, what does it look like, what are the similarities and differences to the lunar regolith. And fortunately, it was very similar. So we can use it. It's a fairly high fidelity or a high quality simulant of lunar dust we can use in our testing. The other thing I was working on writing the proposal, and I spent a lot of time trying to figure out how to do the budget, jumping through the bureaucratic hoops.
I was originally brought on to make a spacesuit for Barbie. That was the way I was approached, with no context for the project. And it intrigued me enough when I was told, hey, can you make a spacesuit for Barbie, that I joined. Now I know the context and I'm still super excited about it. And that is what I will ultimately be doing going forward, is working on spacesuit simulants and helping to find materials that will most optimally represent the spacesuits that are actually used. Before we got the funding, though, I was helping to write the proposal and helping edit it.
My specific role on the team is the experimental specialist. So I'm in charge of the testing, getting the data for the different TRL levels. We first did testing just to verify that the idea was even feasible and that we should pursue this. And once that testing showed promising results, that gave us the opportunity to dive in and work on the proposal more.
My name is Greg Wallace. I'm a graduate student here. I'm helping with advising on parts and construction, and then I'll also be doing some CFD work to go in conjunction with the tests we're doing.
And then I'm the team lead. I communicate with our partners for the project. And I've also been working on developing a imaging system so that we can get some of the data to inform our CFD modeling over the summer.
Awesome, that's really cool stuff. So this question is directed at both Lauren and Camden. So the two of you were previously on the core team. What was it like moving from the core team to the Hyperborea team? Did your tasks change? Were they relatively the same? What kind of things did you think of just in that transition?
All right, I guess I can go. So I was the core team lead, as you guys know, and that was an amazing opportunity to learn about, how to communicate with people, how to get stuff done. And so moving on to Hyperborea, it definitely helped me to have that experience. And I feel like now I'm a lot better with communication. The tasks are definitely different. Now I'm more specifically doing research rather than getting to know the lab and that sort of thing. But yeah, overall, the core team definitely helped me when moving to Hyperborea.
When Ian started with this idea, I had already been working on the core team for about a year. And that is the general time that people spend on the core team. And I was looking for openings in the lab that I would be interested in. When I heard about the NASA project and this proposal, I was immediately very intrigued and interested, and reached out to Ian. He was looking for help, and we started interviewing people right away. It was a really interesting experience to be on the backside of the interview process, and I definitely had a greater appreciation for the interviewer and coming up with the right questions. And then I worked off and on with the core team and Hyperborea at the same time while Hyperborea was getting started. For about the first semester, it was all background work, unpaid work just to get the project off the ground. But once we were accepted, our proposal was accepted, I made the transition from the core team to Hyperborea full time. And I'm really excited about it.
When researching and looking for outside help, were there any people in particular that helped you guys in your research?
I guess for me, it wasn't necessarily specific people. Since I'm doing mainly the safety plan and everything, I've been researching a lot of NASA safety codes and that sort of thing to help us when writing our procedures and when doing the testing.
How was drafting the research proposal for you guys?
In short, it was a process. We definitely did not fully understand when we got into this how much time it would take and how big of a, I guess, commitment it would be. But I think we learned along the process. I certainly learned a lot. Being a sophomore, not having taken some of those higher level engineering courses and knowing how to formally write proposals, it was certainly a learning process. It took a few months of constant work. There were probably hundreds of hours poured into it, all at no pay, which I don't know, it really shows how passionate everyone on the team is, that they're willing to put all this time in. And I think that really came through in the proposal. We heard back that it was well written and they really enjoyed the concept. And yeah.
Awesome. So what was the research like during the time of COVID, kind of the pre-funding approval? So like between like September and December. Like, what exactly were you guys able to accomplish during that time?
Yes, I can go. So as I mentioned earlier, with kind of forming the team, we went into the lab and we essentially got a proof of concept. We then essentially showed this and said, hey, we have an idea that we think can work. We showed that to an industry partner. I'm not sure if I'm allowed to say who it is yet. But they were definitely interested. So we started working with them. And then we went in a few more times and essentially got some better pictures of the whole process. And then finally, we moved on to some, I guess, introductory testing. So essentially, NASA has a like technology readiness scale. So we tried to get our technology to a very intro level before we submitted the proposal to increase our chances of success. So we went in and did some of that introductory testing, just using some rudimentary suit simulants, some Mount St. Helens ash, and some liquid nitrogen.
I actually have a sub question of that question. How did you manage to secure that Mount St. Helens ash?
I don't remember exactly how it started, but there ended up being an email chain primarily between Jake and I think one of the other professors. essentially, Jake knew that WSU had some Mount St. Helens ash that had been preserved since the eruption, like 40 years ago, something like that. And there was an email chain. I want to say Richard Mack. I might be wrong on that. Anyway, essentially, Jake knew this professor who was managing it, and they weren't being used for anything. So this professor offered us a couple barrels of ash.
It's incredible. So now that you guys have your funding from the Big Idea Project, which congratulations to your entire team, that's incredible. What is the next step for your team?
So the next step is to begin testing. So as I mentioned earlier, we did some introductory testing as essentially a proof of concept, and then getting that technology readiness level to a good place. Essentially what we're going to be doing next is refining that a little bit. So we'll be doing some more rigorous experiments, essentially testing for some different variables that may impact the effectiveness of the Leidenfrost phenomenon. So we'll be testing for instance, drop height and angle of inclination of the suit simulant. And the goal of all this testing is essentially to create models of how the Leidenfrost effect works, because there are not substantial models out there, which makes things very interesting. We're essentially making the math as we go. So that's kind of our first step. After that, we will be moving into the computational fluid dynamics modeling, which is over the summer. Essentially, we will be doing that kind of in tandem with some more testing, getting some data and then modeling that data and trying to get the model to accurately reflect reality. And then the ultimate goal, the ultimate next step, I guess, for the project is to build a scale model of our system using, and it's going to be a 1/6 scale model using a Barbie with a sewn astronaut suit.
So that is awesome. Will you guys continue the same work or do something new once your funding is received?
I know. So since I'm working on the safety plan right now, which is definitely something you want to do initially before testing starts. But I know that going into the summer, I'm going to be continuing with safety work and also helping a bit more with the testing. Yeah. I guess, does anyone else want to individually talk on that?
I know for me, a lot of my work is probably going to stay somewhat the same. Like I said, a lot of mine is going to be kind of taking the information we have or that we're getting and putting it into a scientific format, into the format that's laid out with the experimental design thing, just to kind of make sure that we have everything and that it's labeled properly and that it'd be easy to access after the fact.
So going forward, I have a similar role, again, helping the Hyperborea team with materials problems, particularly around with the lunar dust. So now we know that Mount St. Helens ash is a pretty good simulant, but there's still a few final things to check. For instance, we only give a rough distribution of the size beforehand, but now that we have funding, we're going to investigate more kind of some of the other properties of the lunar dust, of the Mount St. Helens ash, and how it acts like lunar dust. In addition, lots to do with testing, right? We have 5 or 6 or 7-ish months until the conference, and so we need to do tons of testing. And so the ash is interrelated, right, with that. For instance, we need to dry the ash before we test with it. And then I'm also working to help develop how we're going to measure our testing. So how do we measure how much ash comes off our spacesuit samples? And in addition, we're working on a couple of journal articles to publish our findings. I'm speaking at a couple of conferences to talk about the use of Mount St. Helens ash as a lunar regolith simulant. Lots and lots of writing. Working on helping to, now that we've won the proposal, working on taking the budget and implementing it into that we can actually use the money, we can actually spend the money. And again, lots more ash problems. I think one of the ways we might characterize our testing is using a scanning electron microscope. And I'm the only one in the group that knows how to use a scanning electron microscope. So different methods like that. Yeah.
Going forward, I know I'm helping a bit with the procedures for building the actual experiments and helping with the setup for that, as well as continuing to help with spacesuit simulants, since that is a bit more my specialty. And eventually making a spacesuit for Barbie.
Obviously, funding gives us the opportunity to actually go ahead and put this from the page and from documents that we had prepared into action. So this week we're actually ordering our first batch of parts for 2 different sets of testing to get data for the peer-reviewed journal paper that we will be writing and for the midterm report. So I'm very excited to actually start building in person and getting moving forward with our budget has allowed us to do that.
Not too much. Mainly just get more into the CFD, computational fluid modeling.
Gotcha. So then one of the last questions we have is, so there's another event in November that you guys have to prepare a presentation for, if I'm correct, right? What are the next steps after that? Like, let's say you make the presentation, you nail it. Is that where you receive more funding, or is your project just approved?
So at least my understanding of it is we will be having all of this testing before this event, and then we will present at this event, and that is kind of the end of the road for specifically this funding source. So I don't remember where it's being hosted, but we will go and present at this event, and we'll be alongside the other finalist schools. There were 7 schools chosen. When we present, we will show all of our data, and that's kind of the end of it, unless someone else expresses interest.
Nice. Well, I think you've answered all our questions. So thank you so much for all of you coming and having an interview with us.
Sweet. Thank you, guys.
Thanks for having us.
Yeah, thank
Thank
you.
you.